Hi everybody, I'm going to be going over lesson 3.1, Algebraic Expressions. Hopefully you've done the activities that you needed to do before you got to this point. So I'm going to go through all the examples and the vocabulary that you see in the book. So the first thing, an algebraic expression is an expression that can contain numbers, operations, and one or more symbols. We call those one or more symbols variables, okay? Parts of an algebraic expression are called terms. So the first thing I'm going to write is what they have in the book, 5p plus 4, okay? So if I look at the two pieces, 5p and 4, 5p and 4, these are both terms, okay? When a number is before a variable, it's called a coefficient. So this number, 5, is the coefficient. Okay, p is known as the variable. This can change. And 4 is known as a constant. 4 is never going to change. 4 is always going to be equal to 4. Okay? So let's look at the first example now that we looked at those vocabulary words. It says identify the terms, coefficients, and constants in each expression. Let's look at example number 1. Okay? It says identify the terms, coefficients, and constants in each expression. So 5x plus 13, okay? The term are both of these numbers, 5x and 13, okay? Plus is an operation. It will not be called a term, okay? The 5 comes before the x, or before the variable, so this is known as a coefficient. X is known as a variable, and 13 is known as a constant because it will not change at all. Now let's look at b. b is a little bit more complicated because we have exponents, so let's take a look at this. So we know the terms are 2z squared, y, and 3. Those are my three terms, okay? There's something special when I have a variable without a coefficient in front of it. There's actually what I call a silent 1 in front of this y, okay? So that's going to drastically change our answer. So if I just look at 2z squared, okay, 2 is a coefficient, COE, coefficient. Z is the variable, all right? If I look at my second term, 1 is the coefficient and y is the variable. And if I look at my last number, 3 is the constant. Okay, so hopefully that makes some sense to you guys and you understand those parts. All right, now I would pause the video and do your own questions to make sure that you've understood these questions. The next question you're going to do is the example 2. This is going to be as follows. Okay, example number 2 says write each expression using exponents. So this is something we did back in section 1.2 on powers of exponents. In this case, I have 3 d's being multiplied, so this would be d to the 4th power. Okay, in this one, just so you're aware, the coefficient would be 1. Okay, 1 in d4, d to the 4th power. In the next one, 1.5 times h times h times h, 1.5 is my constant. It always goes before a variable, okay? But now that it's going before a variable, it will be known as a coefficient, h to the 3rd power. The only thing we're putting to the 3rd power is h, okay? At this time, I would pause the video and do the on your own questions 4 and 5. The next example we're going to go over is example number 3. Example number 3 talks about what happens when you're substituting for a variable. So substituting is a big word in algebra that you're going to be hearing for the rest of your lives in math is substitution. So all it's saying is whenever I see a k, I enter 25. Okay, I keep everything else the same, but I enter 25. So if I'm looking at k plus 12, it's really going to be 25 plus 10, which is known as 35. This is evaluating the expression. The reason it's called an expression is because it does not have an equal sign. The next problem, when I have 4n, also written like this, okay, I substitute 12. Your answer is not going to be 412. It's going to be 4 times 12, okay? And we know 4 12 times is 48. So that would be the evaluation of that expression, okay? At this time, I would pause the video and do on your own questions 6 and 7. The next example we're going to be going over is example number 4. So this again is another substitution problem, but in this case, instead of substituting one number, you're substituting both numbers, okay? So you see that you have an A and a B. So you just substitute exactly what it says. A divided by B is going to be 16 divided by 2/3. Now, no more variables. You know what they are. This could be a keep, change, flip problem. 16 over 1 times 3 over 2. Don't forget, you can reduce inside the problem. 2 goes into 16 and 2 equally. So this is now 8 times 3. My final answer is going to be 24. All right. At this time, I would pause and do the on your own questions 8, 9, and 10, or whatever you are assigned. Be careful on number 11 because that is a multiplication problem. The next example we're going to be going over is example number 5. Example number 5, again, is a substitution, but now you have more than one operation inside the expression. So in A, I want you to think for a second, what are the two operations you see in example 5A? Hopefully you chose multiplication and subtraction. So I want you to think 3 times 15, I'm substituting, minus 14. Don't forget your order of operations. Multiplication comes before subtraction. So I need to do 3 times 15, which is 45 minus 14. And 45 minus 14 is going to be 31. Okay, in the second problem, you have two operations. I want you to think about what those two operations are. Hopefully you chose exponents and addition. So z squared is now going to be 2 to the second power plus 8.5. This is a nice refresher on decimals. 2 squared is known as 4 plus 8.5. This is pretty simple, 12.5. Okay? At this time, I would pause the video to do on your own questions 12 through 15. The last example we're going to do is example number 6, and this is going to be a word problem. So let's take a look at this problem. Okay. You're saving money to buy a skateboard. You begin with $45 and you save $3 each week. The expression 45 plus 3W gives you the amount of money you saved after W weeks. This is saying you're starting with 45 and you're adding 3 times the amount of weeks. How much will you have after 4 weeks, 10 weeks, and 20 weeks? So this, again, you're just substituting in. If I want to know after 4 weeks, I know my W is 4. So 45 plus 3 times 4, and you can get that answer. 10 weeks is 45 plus 3 times 10, and 20 weeks is 45 plus 3 times 20. Those, I all believe that you can get those answers from them. After 20 weeks, can you buy the skateboard? So really, since B is asking us if we can buy the skateboard or not, we should solve for 20. So 45 plus 20 weeks, or 45 plus 3 times 20 weeks, is 45. I'm going to actually erase, and I want to do that problem over. Okay, so I'm going to do 45 plus 3 times 20. Now it doesn't really matter if I put 20 times 3. Due to the commutative property, I can put them in any order. But I'm going to go 45 plus 60, which is known as $105. That's how much money I will save after 20 weeks. Since the skateboard costs $125, I know I cannot, no, I cannot buy the skateboard because I only have $105, which is $20 short to buy the skateboard. Okay? At this time, I would look at number 16 to make sure you know how to do the on your own problems. Hopefully this clarified some of your thinking for algebraic expressions. If you have any questions, feel free to ask me, and then go on to your practice. Have a good day.